Hello, everyone. Today is Wednesday, July 22, 2026, and I am so excited to be here with you all today. I am your host, Sano, and today, I'm introducing a super trending article from the archive. It is a really fascinating paper, and I just cannot wait to dive right into it with you. The title is Adaptive Adversaries, a multi-turn, multi-bone benchmark for all agent security. The core is Oxide OX67 7.18063 won. It is long. But do not worry at all, because I'm going to break it down and explain everything in a super fun and easy way. So what is this paper all about? Well, you know how we have all these amazing AI assistants nowadays, right? Like the ones that help us write emails, or control our smart homes, or even write code for us. These are called large language model agents, or MOM agents for short, and just like anything else connected to the internet. They need to be secure against bad guys, or in this case, bad prompts. This paper is trying to solve a really big problem in how we test the security of these AI agents. Right now, the way people usually test if an AI is safe is by giving it a fixed list of tricky or harmful prompts. It is kind of like a standardized test, where the questions are written ahead of time, and they do not change based on how the AI answers. But that is not how real hackers operate in the real world. Real attackers are adaptive, meaning they try something, and if it does not work, they change their strategy based on what the AI just said. They try to trick the AI over a conversation, which is called a multi-turn attack. This paper introduces a brand new way to test AI security by using an autonomous attacker that actually adapts across multiple rounds. The attacker observes the prior responses from the defender AI, and then pivots its strategy across up to 15 rounds. Meanwhile, the defender AI treats each interaction as a fresh start, which isolates how robust it is against a persistent adaptive attack. And the results are honestly kind of shocking. When they restricted the scoring to just the first turn, the attack success rate was only 0 to 1%. But when they allowed 15 rounds of adaptive attacks, the success rate jumped up to between 5.4 and 14.0%. That is a huge difference. And it shows that static tests are just not enough anymore. Comparing this to other technologies, most existing safety benchmarks use a fixed attack pool. Even when they use clones to generate attacks, they usually generate them once, save them, and use them. But this new benchmark generates attacks live during the battle. Plus, they found that using 3 different top-tier attack realms and covers up to 2.2 times as many unique successful attacks compared to just using the single best attacker. That means different AI models think of different ways to break in, which is totally wild to think about. Now let us talk about how this applies to our everyday lives. I have 3 specific application examples based on this paper that show exactly how this technology could impact the real world. First, think about smart home controllers. A lot of people use AI to control things like lights, thermostats, and even front door locks. In this paper, they actually tested a scenario called Smart Home Jack. An adaptive attacker might start by asking the AI to set a cozy movie night scene, which seems totally harmless, right? But then, over multiple rounds, the attacker might fabricate a fake firmware policy, telling the AI that unlocking the front door is now reclassified as a safe convenience feature. If the AI is not tested against these adaptive, multi-turn tricks, it might just believe the fake policy and unlock your front door. By using this new benchmark, smart home companies can test their AI against clever, persistent attackers, making sure that your home stays perfectly safe and locked up. Second, let us look at automated code reviewers and software development. Companies are starting to use AI to review code and approve it for release. And an attacker could submit code with a hidden vulnerability, like in cell injection. If AI flags it, a normal test would stop there. But an adaptive attacker will argue with the AI. It might say, "Oh, that is a read-only replica," or it is just a static scanner false positive. It uses plausible context to convince the AI that the dangerous code is actually safe. This benchmark allows companies to simulate these exact debates, ensuring that the AI code reviewer stands its ground and does not get talked into approving malware or vulnerable code. This keeps all the apps and websites we use every day much more secure. Third, consider AI programming assistants or customer service bots that might have access to sensitive information. There is a scenario in the paper called memleak. Imagine an AI assistant that has a previous user's database password in its memory. It is programmed to never share it. If you ask directly, it refuses. And an adaptive attacker will change tactics and maybe ask the AI to help test a Regex parser using the project connection string as a synthetic test case. The paper found that some really smart eyes, White Cloud Opus, were actually super vulnerable to this because they wanted to be so helpful with the debugging. They accidentally leaked the password inside the test case. By applying this adaptive testing, developers can find out if their AI is too helpful for its own good and prevent sensitive data leaks before they happen in real life. It is just so fascinating how different the eyes have different weaknesses. For example, the paper showed that while one AI failed at the memory leak trick, another AI, like Gemini, failed completely at a fabricated authority trick, where it accepted a fake official note to accept an academic paper. That proves that there is no single safest model out there. We may need these dynamic, multi-turn battles to find all the weird and sneaky ways an AI can be tricked. I hope you found this as interesting as I did. It is really cool to see how researchers are pushing the boundaries to make our AI tools safer and more reliable. Thank you so much for tuning in today, and I will see you all next time.